Alright, good morning. Now we're doing 5.3, the first worksheet on 5.3, direct variation worksheet. And we're starting right into it. Direct variation equations. A little side note, direct variation equations. Okay, direct variation y equals kx, or if you're solving for k is going to equal y over x. That's important to know. And I look through these all very directly, so that's kind of nice to know. If you were doing the inverse variation, okay, the equation looks like y equals k over x, and if you solve this for k equals y times x. So keep those in mind: direct variation equations, inverse variation equations. Okay? So number one, which equation is not an example of direct variation? So direct variation just has a number times x, a number times x, a number times x. This one does not, because it has a number times x then plus some number. Okay, so this one is not an example of direct variation. Okay, number two, we're just going to do number two real quick. Y equal x, that's good. This is good. These are the only ones I got to check. I'm going to check this one right here. If I take away 2x from both sides, I'm going to get, I see, y equals negative 2x. 3y equals negative 2x. Then divide both sides by 3. Then I have y equal 2/3 times x, which is a variation, which is a direct variation. So one that cannot be would be this one right there. So if I were to work that out, I would get something extra at the end. So 6y, take away 5x from both sides, and I get negative 5x plus 30. Divide everything by 6, and I get y equals negative 5/6x. If I reduce 30 over 6, that becomes 5. So this right here stops it from being a direct variation relationship. Okay, so that's why that one is not. Okay, alright, number three, name the constant of variation, and this will be k in all my equations here. So if I go back to this top, direct variation kx, k equals this. Inverse variation k over x, or k equals y times x. So in this case, k is 5. Okay, really simple to see that. 5 times x, and if it's this form right here, y equal kx. Number 5, k is equal to that number directly in front of the x that I'm multiplying it by. So negative 2 over 3. Real simple to do those. Okay, now number 6, 7, 8, 9, 10. Let me do the evens here instead. I'll let you do the odds. So since it varies directly, I now can go say k equals y over x. I can use that form right up here. And it says y is 16 when x is 8. So that would be 16 over 8, which reduces to 2. So I know that k is equal to 2. Now it says find y when x is 16. So if I know my equation, y equal kx, and k is 2, it wants me to find y. So k is 2 times by what I know about x, which is 16. So y would be 2 times 16, which would give us 32. So there's my answer right there, 32. Number 8 varies directly again. Okay, so that's important to know. So k equals y over x. In this case, v over g. Oops. Okay, so v is 36. G is 4. Divide those out, I get 9. So my k is equal to 9. Okay, and then in my formula, okay, it will be v equals k times g. Not sure why they're using different variables. They just should keep it y and x. find V. So V equals K, which is 9, times G, which is 11. 9 times 11 is 99. So there we go, 99. And the last one we're doing is number 10. Again, varies directly. And it looks like X's and Y's. And Y varies directly, so Y over X again. So Y is 9 over 3/2. Okay, so now this tells me 9 divided by 3 over 2, which is the same as 9 times 2 over 3. So this would be 18 over 3, which would be 6. So that is my K. If you divide this out on the calculator, 9 divided by 3/2, you'll get the exact same answer. So I write my equation for direct variation, y equals kx, and I'm finding y. K is 6, x is 1, and 6 times 1 is 6. So there's my final answer for number 10. Okay, so there's your first handout. Let's see, is there a back page to this? Oh, there's a back. So let's take a look at the back page as well as we're doing this. Alright, 11 and 12. Does the following graph represent a direct variation? The answer here is no. It is no because it does not go through the origin. So no, it must go through origin. Okay, so if I look at number 12, does the following represent direct variation? Oh, this is a yes, because it goes through the origin. And that's all you have to keep track of. Alright, and the rest of this, direct variation word problems, they give you some examples. Step 1, step 2, looks like that's what we were doing in the last problems all the way through. So there's nothing to do here, just look at, they're giving you some examples of word problems there. I'm just double checking this. Okay, so that'll be it. Alright, that's good.